For part 2, we're going to go ahead and determine the axis of symmetry. So remember, the axis of symmetry is simply x is equal to the x-coordinate of the vertex, which is 2. And that's it for the axis of symmetry. For the x-intercept, so remember what we did for that. We set y equal to 0. And from there, we can solve for x. So when we set y equal to 0, we're setting the function equal to 0. So we're setting the function equal to 0, and we can solve for x. And since both terms have an x in common, so this is a factorization problem, we can factor out the x. The nice thing about factoring it this way, and this is what we can do when we have two x terms, is we can set both of them individually equal to 0. So there's an x part, and we can set that equal to 0. And there's a negative x plus 4 part, which we can individually set equal to 0. One of them is solved for us, it's just 0. So over here, we just get that x is 4. Solve for x. And so we get 2 x-intercepts, which is okay. And we'll see on the graph why that's the case, why we have 2 of them now. The y-intercept, what we have to do is set x equal to 0. So again, this one is the easier one, in my opinion. So every x that we had, we just replace it with 0. And we actually just get 0. So that's pretty convenient. So now with all of that information, we can go ahead and graph the function, starting with the vertex. The vertex we found to be 2, 4. And then remember, with these graphs, we need to just find any other point on the graph. So we have a few points. The one I notice most significantly is 0, 0. It's the x-intercept and the y-intercept. And as soon as you plot that, the graph will be provided for you. And that would be it for at least graphing. Now that we have the graph, we can determine the domain and the range. Remember, the domain is all real numbers, just because there's arrows on both the left and the right side. And the range, lowest we can go, which is negative infinity. And then we compare that to the highest we can go, which is, it stops at the vertex. The vertex is 2, 4. And we're looking for the range, which means we want the y value, which is why I'm putting 4. And then a bracket. That would be the range. And also figure out the increasing and decreasing intervals the same way we did before. For increasing, again, think about it as a roller coaster. When are you increasing in height? It's where I drew the, where I shaded the graph in blue. So what is that interval? If anything, the left-hand side seems to be negative infinity. And then the right-hand side, where the increasing stops, is at the vertex. Increasing and decreasing only uses x values, and the x value of the vertex is 2. So we know that it stops increasing at 2. And if it stops increasing at 2, then if it stops increasing, then what does it have to do afterwards? Decrease. Which is why we would proceed to decrease from 2 to positive infinity, or visually, the part I am highlighting in red. So that would be the increasing and the decreasing intervals for this graph here. So from here, we shall go ahead and move on to example 5. So now we're going to move on to something a little bit easier, actually. So for example 5, it says, determine whether the given quadratic function has a maximum or minimum, and then figure out that maximum or minimum. So how do you figure out if a quadratic function has a max or a minimum? Well, it's good that we know a visualization. It's a parabola. A parabola has a maximum if it's facing downwards, and a parabola has a minimum if it's facing upwards. It's just simply by virtue of, do you create the lowest point of a valley or the peak of a mountain, just based off of the shape. And so we can use the leading number to determine that. So that's how you determine if a graph opens up or down. For part 1 here, the leading number is a -3, which means that this will be facing downwards. And so since we have a parabola facing downwards, that means we're going to have a peak or a maximum. And then all at once now is the y value of the vertex, the value. So if anything, to figure out the y value, we have to figure out the x value first. So it's -b over 2a. -b, so b seems to be 24. A seems to be -3. And this seems to be +4. So -4 divided by -6 is +4. We plug that back into the original function to determine y, or the y coordinate of the vertex. So I'm going to erase that stuff below. So I'll rewrite the x coordinate up there. And so to figure out the y coordinate, we plug in 4 for every x in the function. And I'm just going to do this in the calculator. I get 41. So that would be the maximum value. And that would be the answer. Part 2, same thing. Start off by looking for, does it open upwards or downwards? It opens upwards because the leading number is positive, which implies that we will have a minimum. So it opens upwards, which means there is a minimum. But despite whether it's a minimum or a maximum, we still solve for the vertex the same way. So b here is -12. The a value is 6. So that just seems to be positive 1. It's minus negative 12, which is positive 12, divided by 2 times 6, which is 12. And we get 1. Now for the y-coordinate, we just plug in 1 into all the x values. And so here it's just 6 minus 12, negative 6, minus 1 is negative 7. And that would be the final answer for that second problem. So we have three more problems left. So let's go ahead and look at those. So there is something else called a vertex form. And we've actually seen it before. In fact, it was the form of the very first function on this section. The reason why we call it vertex form is because we need the vertex in order to construct this quadratic, just like how slope-intercept form is built off of the slope and the intercept. Vertex form is built off of the x and y coordinates of the vertex. And so that form in particular is, as I just highlighted, a times x minus h squared plus k. And the h and k, that represents the x-coordinate and the y-coordinate of the vertex, respectively. So if you know the vertex, you can build the function. So for example 6, let me write this at the bottom. So for example 6 here, they actually already give us the vertex. So that means if we're trying to determine the quadratic function and they give us the vertex, that means we can fill in the vertex with h and k respectively. So what's the x-coordinate of the vertex? It's positive 3. There already happened to be a negative sign in the formula, so we have to leave the negative sign. And then plus k, what's k? It's negative 13. So that's why I'm making this minus 13 or negative 13. And you might notice we are not done yet because we have to figure out a. So there's that value a over there. We don't know it, and we can figure it out. That's why in this problem, they give us this point over here. Because what this point does is it gives us a temporary value that we can utilize in order to solve for a. So this is going to be scratch work. I'm going to do this in red off to the side here. So for y, I'm going to replace y with negative 4 is equal to, and I'm going straight from here off to the side. And I'll come back to that. So a, we still don't know it. What is x? X is now 0 minus 3 squared minus 13. 0 minus 3 is negative 3. That squared is 9. So that's times 9 minus 13. Or in other words, this is 9a minus 13. We can add 13 on both sides to get 9 is equal to 9a. And then we get that a is 1. So we did all of that just to put that a is 1. Which doesn't really do anything because a is multiplying the function. But if you're multiplying by 1, it doesn't really do anything. So we can conclude that this is the answer. We found h and k because they were given to us at the beginning. And we found the stretch or compression, which just ended up being 1. And that's all you'd have to put. You can leave that form. So 2 more questions. Example 7, pretty much the same problem, but without a graph. So they give us the vertex, and what they want us to do, it's the same problem, but they ask us to go one step further. So there's really several ways you can do this problem. I think the best way is to utilize the vertex of 0 and 4. So remember, the vertex gives us h and k for the x-coordinate and the y-coordinate. So we're going to plug those in directly. So that would be x minus 0 squared plus 4, because I plugged in h and k. And we can actually clean this up a decent bit, because x minus 0, well, subtracting 0 doesn't really do anything. So x minus 0 is just x. And so we get ax squared plus 4. Now, if anything, so the way this is going to, the problem is going to ask you this, is it'll say a is equal to blank, b is equal to blank, c is equal to blank for the for this premise of find a, b, and c. Now, I claim we already know 2 of these 3 already. And that's because this form alone, well, let's compare that form with the generic form. In the a place, it's still a, so we don't know that one. What's in the b place? So what is the number next to a solo x? There isn't one. So that means b would be 0. And then what's the constant c? Is 4. So if anything, we already have 2 of 3. So how do we find a? Well, this is what we did in the last problem. We plugged in that extra point that was provided to us. In this case, that extra point is 1, 5. So we're going to plug that in for x and y. So we're going to plug in 5 for y, so we're going off of this. We don't know a, and we're going to substitute 1 for x. 1 squared is just 1, so that doesn't really do anything. And we get that a is 1. So perfect, a is 1. It doesn't really want an equation, it just wants you to fill in those values individually. And so that's all you would have to do for this problem. And so we go to the last problem in this section. It's talking about the marginal cost. Now, I'm just going to give a kind of hint. For the marginal cost, there is one thing that just tells you exactly what to do. I think there's like 2 or 3 problems that ask you to either maximize or minimize something. And all that means is you're going to find for part A, the x-coordinate of the vertex, and then part B will be the y-coordinate of the vertex. And that's because minimize as well as maximize for those problems, maybe a revenue problem, they're asking you to find the minimum or maximum value of a parabola. And as such, and in fact, the parabola in this problem, or the quadratic, is at the very end. All the other words are just garbage because they give you everything. So we can simply determine or find v of x, which is the x-coordinate of the vertex for part A. So that's simply negative b over 2a. A is 1, and b is negative 120. So minus negative 120 divided by 2 times 1, and that just seems to be 60. So that actually answers part A. So for any problem that asks you to find a minimum or a maximum, you're just finding the x-coordinate and then the y-coordinate of the vertex. That might help you with 2 or 3 of your homework questions right there. And so part B, like I said, this one wants you to find the y-coordinate. Oh, what am I doing? Sorry. You take the answer from the previous part, you plug it into every x. So now 60 squared minus 120 times 60 plus 7,600. Just a calculator problem from here. And I get 4,000. That would conclude this problem, as well as the remainder of this section. So I hope you enjoyed this lecture. So take care.